Hi friends, in this video let's have a look at problem 2390, removing stars from a string. We are going to explain a solution based on the practice of stack abstract data type. So here we are given a string S which contains stars. So in one operation we can choose a star and then choose a closest non-star character to its left and then do the deletion. So we delete both the star and the non-star character. So we are required to return the string after all stars have been removed. So here are some additional notes. First, the input will be generated such that the operation is always possible. So in other words, this note actually says something about the test cases. Basically, all the test cases after we removing the stars and the corresponding characters, then the result will not contain star anymore. And second, it can be shown that the resulting string will always be unique. So this is a very easy reasoning, right? Here are two examples. In example 2, so we see that there are 5 stars, and to the left there are 5 characters. So we can remove all the stars and characters, right? So we are going to left with a empty string. In the first example, so we have 2 stars here, then we can remove E and T to the left, and we have 1 star here, we can remove D. So the result will be LECOE. So with that said, let's also look at the constraints. First, the length of S is unbounded above by 10 to the power 5. So this number, 10 to the power 5, basically defines the upper bound of the problem size. Secondly, S consists of lowercase English letters and stars. And the third one, the operation above can be performed on S, right? So we can always perform the operation, it means. So with that said, actually we are ready to do the analysis. So we are going to give a treatment based on stack. So actually this is a standard application of the stack abstract data type. So as such, we directly list the algorithm or steps, and then we go to coding. So the algorithm is as follows. So first we are going to initialize a stack, and then we do linear scan for the string S. That's the step 2. So if the current character is string, then we do a pop operation. So by the assumption in this problem, we can always do the pop operation. Then otherwise, we are going to append the character to stack. And finally, step 3, we join the characters in the stack to return the result. So this is the algorithm we are going to code. So now let's look at the coding part. So first, let's initialize a stack. So here I'm going to use this list to mimic the stack behavior. Here, basically what we want to use is the order behavior. That is last in, first out, right? LIFO. So this is to distinguish with queue, right? Queue is first in, first out, right? So now let's write the second step. That's the linear scan. So for a character in S, right? Then we're going to check the character. If character is star, in this case we are going to do stack on pop, right? And otherwise, so what we're going to do so is that because this current character will be just a plain lowercase English letter, so we just append, right? And then after this for loop, we finished step 2, and then we're going to return the result. That is the join of elements in the stack. So this shortcode actually forms a solution format to this problem. So before we make any comments, let's first do a check. Appendix, okay, so here, character. So now it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So this actually about it for this specific problem. However, let me make this code a little bit longer to deal with more wider case. So let me change this one to be version v1. So here in step 2, so if the current character is star, we do a pop operation. So actually in general, this may be not the case because the stack can be empty. But due to the note 1 here, so the because the operation is always possible, so we can always do pop. The test cases basically guarantee that the stack is not null. So now, if in more generally, so what we want to do actually is here. So we are going to do a check. So if stack add stack -1 is not a star, right? Then in this case, we can do the pop the left non-star character, right? Otherwise, actually, either the stack is null or the stack -1 is still a star. So in this case, we are going to use stack append. So we need to append this character. So this is in the if block. So we write with in some sense verbosely. So in the else block, we need to do the append. So then finally we join. So this code, the second format, deals with more wide cases. First, let me check for the current test case. Yeah, it passes all the cases because it can deal with more. But the thing here is that if we have too many stars, and then we can reduce as many stars as possible. So for example, here is a test case. So we have many stars, and then we have just one character to the left. Then we can reduce A and 1 star. Then we remain a number of stars ending with BC, right? So, but this one actually corresponds to invalid test cases, but we can still test the result, right? So here we can do things like this. So here I'm going to change this as to be A. Let me write 3 star and BC, right? So this is going to return star star BC. So this is a wider test case, right? So now let's check. So yeah, the output should be like this, right? This is our output. Actually, this is what it returns because we changed this s. So this one is what we expected. So with that said, basically that's about it. Let me comment out this part and then do a last test. And then we're going to end this video here. So with that said, that's it. Thank you.